Hey guys, Patrick here. So one scenario that happens to me all the time in tree work, in residential tree work, is if I'm taking a tree down, I've already taken the crown out, rigged it down, whatever, I've chunked down some wood, and now I'm left with a good sized peg. And usually what I'll do is I'll tie a rope to it, I'll come down, and then I will hook up some type of mechanical advantage system to it before we actually fell it, just to make sure that I have a good pull on the peg. So it becomes obvious what you should do instead in many situations. The best way of doing it, I should say, would be to put a block right on the tree, a snatch block, right? Which would double whatever input force you want to add to pull that peg over. But one problem with that is sometimes you might be worried when the peg comes over, if my hardware, it might get smashed. You know what I mean? It might land on a log or concrete, asphalt, whatever. So I don't necessarily want to use a good piece of hardware up top as a snatch block. So one thing I've been wanting to find for a long time would be an alternative to a snatch block to use in a case like that. And I think I've found something that might work, and I wanted to share it with you guys. I found this on the Tree Buzz forum. There's a guy there named Dave Swanson. He goes by the nickname Shadowscape. And he showed a setup using what are called Snatch Rings. And these are aluminum rings. They're really popular in the off-roading community. There's actually a YouTuber named Robert Pepper who has a series of videos where he's looked at these snatch rings and tested them. I'll put a link. He's from Australia, but I'll put a link in the description and you can check out his stuff on these. But I'll show you what a snatch ring looks like here. Okay. So this is an example. This is just an aluminum ring. It's rated, okay? It's 9/16 rope, and it's rated breaking strength of 30,000 kilos with a working load limit of 15,000 kilos. So this is cheap. This was around about $22 US on Amazon. So to compare it directly to this is a beast size X rigging ring. It's the same outer diameter as a beast ring, but it's much skinnier. Okay. And so let me just show you real quick here. Give you an example of what I'm talking about. So what makes a snatch block, why they call it that, is its ability to open up in the middle to accept the belly of a line, so that I can put a rope into it without having to find the end of the line to feed in. You know what I mean? That's what makes a snatch block a snatch block. So I'll show you how these rings are used here. The reason they call them snatch rings is because they are used in conjunction with these soft shackles, okay? So the way that these are set up is you can take the belly of rope, you can insert it in the side of the ring like this, and then you can put your soft shackle through it, and you can hook it up to a sling like this. Okay, so this is how these are used. So they're always used with soft shackles. Okay, and then when it's under load, the snatch ring rotates on the soft shackle on this chafing sleeve to provide a low friction alternative. I hope you can see what I'm showing you there. To provide a low friction alternative, to a snatch block, okay? So That's the concept of a snatch ring. So I want to run it through a series of tests and just show you, because whenever you show these or talk about it, everyone will just say, ah, that's silly, you should just use a block. So I want to actually look at it with load cells, put it under tension, see how it's reacting and how efficient it actually works as a pulley. And I'll give you guys some numbers, okay? So I'm going to set up some stuff here and I'll be right with you. Before we pull anything, I wanted to mention I had some issues the other day with calibration on these load cells. So I just want to show you my starting point here on the load cells. Okay, both of these are freshly calibrated back to 0. So what I'm going to be comparing is this snatch ring off of Amazon compared directly to an X-rigging ring, beast size 38 by 28, compared to a snatch block, my old CMI. Okay, so I'm going to start by setting up just some static pulls, just to give us a baseline for efficiency of these three, and then we'll look at some use cases if you wanted to use a ring like this. Now, I want to make sure I say at the beginning, I do not advocate for using, you know, cheap stuff off of Amazon for tree work or whatever. Where I see using something like this cheap snatch ring is, you know, if you can find a decent quality aluminum ring, you might want to use it in a situation where there's a good chance it's going to get smashed. You know what I mean? As I said earlier. So I don't want to smash a good X-ring. You know what I mean? I don't want to smash a good block. But if I can find something cheap that's actually decent quality and has ratings on it, meaning that it's been tested, then it's not so bad, okay? So give me a minute here and I'll get some stuff set up. Okay. All right, guys, so I'll show you what I got set up here. I have a fiddle block, 5-to-1 with a load cell. I'm using KM3 for this test, just because it has the lowest stretch of any rope that I have, okay? So between these two anchor trees, it's about 25 feet. It's about 8 meters. So I'm running through my 5/8 CMI pulley, and it runs all the way back to the second load cell, okay? So on an input of 2.04 kilonewtons, I am getting, on the other end, I'm getting around 1.86. Okay, so that'll give me, I'll do some math there, that'll give me an efficiency rating for this pulley. And then next I'm going to try the snatch ring, okay? The cheapo Amazon snatch recovery ring. Exact same setup with an input force of 2.1, call it. I have an output of 1.58. Okay. So next I'm gonna do the exact same thing, but with a Beast X rigging ring, just to compare it. All right, give me a second. Okay guys, so here I have my X rigging ring being pulled exactly the same, with an input of 2.24 and an output of 1.78, I'm going to call it. It's fluctuating, okay? So if you do the math, I think the X-ring is a little bit more efficient. I had never even thought of using X-rings in this way, so this is really interesting to me. Just for fun, I'm going to include a couple more things. I'm going to do an old rigging shackle, one of these guys. I just want to compare, and then I'm going to do a steel carabiner, just to get some baseline numbers here. Okay, give me a second. Okay, guys. So this is my shackle. I can start calling it a snatch shackle from now on, maybe. Same setup on an input of 2.08. I have an output of 1.30. Okay, so definitely moving down in efficiency. And before we move on, I just want to throw a steel carabiner in there just to give me some ideas. All right, so for the last calibration here, I have an old DMM Steel Carabiner. Same setup. On an input of 2.14, I'm getting an output of 1.28. Okay, so now that we have some baseline numbers to work with, I just want to run through a couple common scenarios. I messaged Dave Swanson on Tree Buzz. He gave me a few ideas of how he uses the Snatch Ring for tree work. So I'm going to set a couple things up and I'll show you guys, and then we'll compare them to other setups, okay? Okay guys, so the first scenario where I might use a Snatch Ring in tree work would be, as I said at the beginning, on a peg at the end of a removal. Instead of just tying directly, I'm going to put a snatch block, or a piece of hardware up top to convert it into a 2-to-1. So for this first test, I did use an actual block. Okay, so I've moved my load cell to the load, and I have my snatch block here, and I am pulling on that with my fiddle block. Okay, this is the other end of the line, is terminated at the anchor. Okay, so in this setup with an input of 2.04 kilonewtons, I am pulling on my load here with an output of 4.09. Okay, so to compare that, I'm gonna switch out the snatch block for the cheap Snatch Ring and just see what kind of numbers we get. Okay, so next setup is the Snatch Ring doubled over, and I'm pulling with about, just call it 2.0 kilonewtons, with an output of 3.43. Okay, so I'll put some numbers on the screen there for you. I'm going to switch that out with an X ring, the Beast Ring, just to compare. Okay, so for the last setup here for a 2-to-1, I have my Beast Ring. Okay, so I'm pulling on it with about 2.04 kilonewtons for an output of about 3.8 kilonewtons. Okay, so again, that's a bit more efficient than the cheap ring. It's probably the anodizing, I would guess, on the X rings. It makes them even lower friction. So that's just a straight 2-to-1. The next setup that I wanted to try is a trucker's hitch, a 3-to-1, but built with these snatch rings. So I'll show you what I have here. I have the one snatch ring that I was using with the soft shackle. I also have a second one that I spliced onto a sling here. Okay, so I'm gonna use these and set up a quick 3-to-1 and give you some idea of what you can pull with that. Okay guys, so I have a quick 3-to-1 setup here using these snatch rings. I'll show you. So I have tied the terminal end to the inside of the ring, kind of like a becket. So it runs from there, it runs back to the anchor on the snatch ring, and then it runs back around the snatch ring to my input here. Okay, so on an input of 1.74, I'm getting an output of 4.09. Okay, so just for comparison, I'm going to take the exact same thing, but I'm going to swap out the rings for pulleys. Okay, give me a second. So exact same setup here, except I've switched out the rings for pulleys. So this is up front, 2-inch rescue pulley. And at the back, I have a pinto rig. Okay, everything else is the same. So on an input of 1.76, I have an output of 5.07. Okay. The last setup that I want to try with these snatch rings is, it's actually called a Spanish Burton. I didn't know that. It's basically a 2-to-1 pulling on a 2-to-1. Okay, so it's a theoretical 4-to-1, but yeah, I'm gonna try it. All right guys, so this is the last setup that I'm gonna do today. This is a 2-to-1 pulling on a 2-to-1 built out of snatch rings with 2 lines. So I have the orange line and the black line. They both terminate at the anchor. Okay, so the orange comes up to a snatch ring here, which is the input. So this is a 2-to-1. This is riding on the input of the black line, which is down here on its own snatch ring. Okay, so with this setup, on an input of 1.98 kilonewtons, I have a total output of 5.7. Yeah, I'm just going to call it 5.7. Okay, so that's an interesting setup. I've never actually done that before. Dave asked me to test that. Spanish Burton, 2-to-1 pulling on a 2-to-1. I'm going to do one more test and then I'm going to wrap it up. I'm going to substitute my X ring for the closest snatch ring here, the one that's closest to the input. And I just want to see if that makes any difference. I think it'll make a small difference, okay? So let's see. All right guys, so this is the last setup that I'll be testing for this. I just swapped out the second snatch ring for a high quality X rigging ring. So on an input of 2.1, I'm getting an output of 6.35. Okay, so that's a good result. I'll do a bunch of math and put it on the screen for you guys, and I'll put it in the description so you can see what the results of all these tests were. In terms of using cheap snatch rings like this off of Amazon, like I say, the reason I would do this is in a situation where I thought a piece of hardware could get smashed. If you want to use them more regularly, I would just use X-rings. A lot of guys already have X-rings lying around. They work better anyway. I think that the anodizing is probably what's causing them to be even less friction than these Snatch Rings, and you can use them in the exact same way. So, I mean, make up your own mind. Don't take my word for it. Hopefully this gives you some insight into using a product like this. If you're gonna experiment with something like this, just make sure you get something that's rated, it's been tested. You know, it's an aluminum ring made in China. They're cheap and strong enough. And if they get smashed and you lose $22 in this case, well, whatever, right? So hopefully that helps someone and gives you some idea. So until next time.